Our soil is made up of many organisms: macrofauna, mesofauna, microfauna, microflora. Macrofauna, these are living things such as centipedes, millipedes, roly-polies, ants. Mesofauna, these are smaller than macrofauna. These are termites here, you see. Microfauna, this is microorganisms living in it. Microflora, this is chlorophyll-producing plants that are microscopic. Two of the most important components of our ecosystem, ants and earthworms, break up the soil, creating holes, creating tunnels for air to get through as well as water. If it wasn't for them, they're on 6 of the 7 continents, Antarctica being the one they're not, we wouldn't have the plants and trees that we have now. One of the things you have to remember is when we're farming, using agriculture, we are removing nutrients from the soil because we harvest that corn or that apple or that wheat, which the energy to build that came from the soil. The nutrients came from the soil. So when we're harvesting it, we're taking it away. It needs to be added back to either fertilizer, manure, similar chemicals. Important parts of the habitat for plants, agriculture in general, is there enough water supply? Or maybe too much water in many instances. The temperature, is it warm enough to grow those crops for a long enough period of time? And absent toxicity such as salt. That's why you don't see a lot of crops close to the ocean coasts, because of the salt from the beaches. You remember this table from our first class, the periodic table? I want you to look in the upper right at N, nitrogen. Nitrogen is one of those most important aspects of agriculture, which we'll talk about over the next few slides. Crop rotation is probably an example of putting nitrogen back in the soil. Like I said before, we are sucking nutrients out of the soil when we harvest. We can put it back in. Such things as clover will add nitrogen back to the soil. You'll see in the next slide they actually create nitrogen. This is called crop rotation now, and you often see it. Areas where they will plant crops and areas where they'll have something they're not going to harvest but let go back in the soil naturally. Clover is legume, as are potatoes and carrots. They are nitrogen fixers. If you pull up any common clover, you'll see the roots underneath have this little white bulb. That's actually nitrogen drawn in from the clover being put back in the soil. Unfortunately, fertilizer has an upper limit. As I've often said, the American way is if 1 pound is good, 2 pounds must be better. The truth is, excess fertilizer will not be absorbed by the plant, but will run off, causing eutrophication, which causes all the algae and ponds, killing everything else. Part of the reason we have insecticides is because of insect pests. As you can see, the top 3 pictures are European corn borers. You couldn't eat that corn, nor could you sell it in the store if it had it. On the bottom, that's ladybug eating aphids. Aphids are notorious creatures that destroy a lot of crops. And then on the right is a cushiony cotton scale, which destroys orange groves. Similar to insects, there's also funguses. On the left, this is called corn smut. It's actually a fungus. That's the same thing as an insect would do. It eats it, you can't buy it. On the bottom, on the right are watermelons, and you can see these black spots and the gray spot in the upper left watermelon. It's fungus from sitting in water for too long. Problem is, you really can't hang watermelons. They sit in the ground because they're so large. There's even some microorganisms that affect plants. The tobacco mosaic virus, while tobacco has almost no enemy, most animals will get very sick from eating even one leaf. There is a virus that can get, as you can see right here. Here's the problem. This is a crop in China, actually, where they're not following putting nitrogen back in the soil, planting regimes, crop rotation. You suck the nutrients out, nothing's going to grow after a while. And here's one of the problems. Here in the United States, we have a lot of cattle and a lot of pigs. In Wisconsin, where I'm from, there's 6 million people living there and 8 million cows. The average cow makes 40 pounds of manure a day. Multiply 8 million times 40 pounds times 365 days a year. It's a lot of manure. There's actually a whole science into manure control. A lot can be used for fertilizer, but it is a science where they have to process it properly, so it does not cause problems to the environment. And in the Carolinas, where there's a lot of pork industry, they have the same issues.